So I was talking about this topic. Okay, some of yani we have to talk about the drag force. So drag force is basically that force in which we yani we have to look into the matter के drag force basically करती क्या है, what are the functions of the drag force, etc etc etc. Okay, so this was the point where I told you, okay, when we have the drag force always oppose the motion of the moving bodies. So when the resistance will be, yani when the air resistance will be zero, the speed will be zero, the drag force will be zero. So here, the object has just started its motion. So when the object has just started its motion, so did you notice what happened? U is equals to zero. When U is equals to zero, then all the speed or all the um, you know sorry, all the force which is there, that is a weight force. So that weight force is the only force. Drag would not be there. But एक minute, where is that? Oh yes, sorry. Here, this was something different. When an object is falling down, just see, when an object is falling down, what did you notice? The drag is in upward direction. Yani, drag is in the upward direction. Drag always oppose the direct motion of the body. And when the object is moving upward, then drag is downward. Yes. So this was shown in these two diagrams for you. So at the top of the motion, now I am explaining that what happens to the drag at different positions. When the drag is when the body has initially zero speed, then drag is zero. Yani at the highest point, what do you think or what do you expect, that there would be no drag?
सर
Yes.
गलत स्क्रीन या तो शेयर हुई भी है
Acha.
क्योंकि हमें तो वही वन नोट के नोट्स पे भी नजर आ रहे हैं स्पीड ऑफ
Okay.
मूविंग ऑब्जेक्ट फोर्स का
Oh, I see. मैं भी वन नोट पर था, लेकिन वन नोट के मेरे पास दो सॉफ्टवेयर हैं. Oh my god. Just a second. Just a second. Yes, I was at this one. Yeah. Okay. Now is it visible to you?
यस
Sorry यार. Sorry for inconvenience. बाकी बच्चे तुम लोग बोले ही नहीं हो. ठीक है? So I was saying that at the top of the motion, when the object as it moves down, or the object is moving upward, whatever that is, at the top of the motion, the speed would be equal to zero, so that the drag is just nothing. So drag goes to zero. So the only force which is acting at that point, that is your weight force. So as the speed increases, what happens? The drag increases. And when drag increases at a certain speed, the drag becomes equal to the weight force. This is really, really important. I'm just directly reaching to the terminal velocity concept, that what happens at certain point, the drag and your terminal velocity, sorry, drag and weight force becomes equal. At that time, the object has no net force. Did you notice this thing? Object has no net force. When the object has no net force, actually at that time, acceleration goes to zero. When acceleration is equal to zero, so the body moves with a constant speed, and that is called your terminal speed. What do we call it? That is called your terminal speed. Is this all clear to everyone?
यस
Yes, sir. Clear.
Okay. Then at terminal speed, yes, this all I told you about this all. So sometimes we are asked about a question that the object is moving with terminal speed, moving downwards. This is important thing. You have to hunt this word, that object is moving with terminal speed downwards. So at that time, drag will be equals to weight. So weight is what? Mg. And drag is what? F drag. F drag is equals to 6 pi eta r into V terminal. So you can find out terminal speed from here. If you know the weight of the object, if you know the coefficient of drag or viscosity and radius of the object, you can simply find that what will be the terminal speed obtained by the object. So this was basically related to your drag, and I will go back to the drag along with the upthrust, that how does the drag and upthrust correlate with each other. So here, when I talk about upthrust, the mostly asked questions from the forces are from the upthrust. So the first reason, that is, yani this is not the exam stuff. It is just a perception, yani daily life observation, that what is a drag, sorry, what is the upthrust. So upthrust is a force which tries or which tends a body to make to float it. Actually, it floats the objects. Like, for example, if I tell you that we have a vessel, and that vessel is having some sort of weight, and that weight is acting downward, then there will be an upthrust force that will make this object or this vessel to float up. So this is upthrust. So it is not like upthrust is just acting in liquids. Upthrust is acting in all type of fluids. So actually, upthrust is the property of fluids. Are you getting my point?
Yes, sir.
So in fluids, fluid can be your water, any type of liquid, and that can be your air. So as I told you that we are talking about the fluid. So drag was also coming from the fluids. So if you simply say that upthrust is having the same behavior, yani upthrust has a relation with fluid. So I can tell you that upthrust is the force that due to appears on the objects which are partially or totally submerged. Yani, if an object is partially or totally submerged in the liquids, then what will you have? You people will have an upthrust acting on it, right? So that is condition. Yani, the condition is there must be the object must be sunk into the object must be basically into the water. Sorry, into the liquid, into the fluid, rather. Is it clear to all? So just see here that if I have an object which is basically completely submerged in the water or in the liquid whose density is rho. Okay, are you getting my point? Hello, do you people
Yes,
hear
sir.
me?
Yes, sir.
अगर आवाज नहीं आए तो मुझे बताना है बीच में, अगर आवाज मिस हो जाए तो, ठीक है
Okay.
ना? Okay, so if I say that the object is uh, basically uh, submerged in the liquid, and that object is uh, having some sort of volume, and that is what, that the object has submerged in a liquid whose density is rho. I have mentioned all these points here. The density of the liquid is rho, and height of the object is h. This is the height of the object, and the pressure at the top of this liquid, sorry, this object is rho g h, and the pressure at the bottom of this object is basically rho gh2. Rho gh1 is the pressure at the top because height is h1, and at bottom it is rho gh2. So did you think that the pressure at the top is rho gh1 and pressure at the bottom is rho gh2? So if I take the difference of the pressures, so what did I get? Just move on. Delta P. So what is delta P? Delta P is basically equal to rho g h2 minus rho g h1. So rho and g can be taken out common. So h2 minus h1 is that height of the object. Is it? Is it clear to all?
Okay.
Yes, sir.
Okay. So just simply say that upthrust, yani this is the change in pressure. Actually, this is the difference of pressure. So if I say that the pressure is equal to force per unit area, or pressure is equal to force into area. So if generally the force is equal to pressure into area, then the force which is upthrust, that is equals to delta P into A. What is that? delta P into A. Is this clear to all of you? Yani, upthrust is the force which is due to difference of pressure. Upthrust is the force which is due to difference of pressure. So this is the definition. You have to write this definition in an exam, that the upthrust is the force which is caused, this is not equal to, that is caused due to the difference of pressure between two surfaces of a submerged object or submerged body. So if I simply say that upthrust is equal to delta P into A, so what was the difference of the pressure? Rho GH, am I right? And rho g h into a. So you just talked about कि यार rho g h into a क्या होता है? Isn't it volume of the object?
Yes, sir.
Is it? So volume of the object is this one. It means the upthrust has a formula of rho gv, where rho gv means the rho is the density of the liquid, G is universal gravitation constant, and LV is the volume of the liquid, or simply say the volume of the submerged part of the object. This is very important. This is not the entire volume of the object. It is only the volume of submerged part of your object. Is it clear to you?
Yes, it's clear.
Okay. So if I say that this all is basically a sort of uh, you know a sort of topic in which we have to take care of this area which is submerged in the liquid. So upthrust is equal to mass into value of g. Why? When I say that the liquid density of the liquid is rho g, what is equal to that? That density is equal to mass of the liquid divided by volume of the liquid. So volume of the liquid and volume of the liquid is gone. So upthrust is technically equal to the weight of the liquid displaced. What is equal to? What is upthrust equal to? That is equal to weight of the liquid displaced. Right? Are you getting my point?
Yes, sir.
Yes,
Okay.
sir.
So when it is equal to weight of the liquid displaced, so um, we can simply say that it is Archimedes principle, actually. You will hear me?
Yes, sir.
So Archimedes principle is something this, that then the we have to perform some calculations on the basis of this. If we are, if we say that we there is an object which is filled with fluid like air, then it would have an upthrust. That is why, when we have the balloons with a gas filled balloons, so they move upward, isn't it? Because they have light density and they are just floating in the surface, floating in the air. That is why when we talk about this upthrust concept, upthrust is very simple. So direction of the upthrust हम लोग बात करेंगे. Upthrust is always directed upward, right? Because it tends to just float your object up, float your object. So when you say that it is the floating of the object, it means the that is the force which has to act upward. So if the force is not acting upward, it cannot make the object to float, is it?
Yes.
Okay. So simply speaking, that if I say that the magnitude of its magnitude is always constant. This is really important sentence, that the magnitude of the upthrust is always constant. The reason behind that is because when you uh, I mean when you just consider the upthrust is equal to volume of the object, na? So just tell me one thing, that whether the object is submerged in the liquid, is its volume change when the object is inside? If the object is rigid, then do you think that its volume is changing? Nahi na? So if density is not changing, if density is not changed, right? This one, value of G is not changed, then V is constant. It means upthrust is constant wherever the object is placed. There are different questions asked to you that an object is moved upward at position 3, there is some force, upthrust force, that is same as position 2, that is same as position 1, but as it is moving upward a slightly out of the liquid, then upthrust would be decreasing. When the upthrust would be decreasing, if you are holding the object by some force, that force you have to apply more force. Is this all clear?
Yes.
You have to go through this, these all. Basically this is really important stuff, what I have provided you for the exams point of view. Okay, now the combination of upthrust and the drag. As I told you that I will talk about that in at the end of this topic. The when we talk about upthrust and drag together, drag can change the party. For example, if the object is moving upward, the drag would be acting downward. But if the object is acting upward, drag would be acting downward. But upthrust would always be acting in the upward direction. So simply speaking, if I say that there is an object in which the initially, yani initially there is only weight, but upthrust will be there. After some time, as the speed increases, drag is taking place, upthrust is there, and weight is there. So if the object is in equilibrium and in resistance at constant speed, what is there? What is there? That upthrust and drag combinedly equal to weight. That is why the body is at rest. I mean, body is at equilibrium. Is this clear to all?
Yes, sir, clear.
Yes, sir.
Okay. In the same way, if the terminal velocity is smaller, then the object would, yani the drag force will be smaller, and the at terminal speed the drag force is maximum. Yani drag force can be highest when the object is at terminal speed, right? So speed does not increase beyond that. It means drag cannot beyond increase beyond that. So when your cars are having the maximum top speed, they have the highest friction and they are actually overcoming the friction at that time. So drag is very small at the rain drop. This is another MCQ question. It is asked that you are having you have a rain drop and you are supposed to calculate or sorry, identify the drag force on that. So on the rain drop, weight is very small, upthrust is large enough because it gains the terminal speed very earlier. That is why its drag is very small. So you are asked, literally there is a question that which option is correct in the order of increasing force and decreasing force. So that is why I had just put both the answers in front of you, that for increasing order, d is smaller than u and u is smaller than weight, or in other words, weight is larger than upthrust and upthrust is larger than drag. Okay, but when you are going to drop a steel ball or a heavy object, then its weight would be definitely greater. So when its weight will be greater, upthrust will be small, drag will be larger. Why? Because it gains very high speed, which is equal to now terminal speed. So that is why your upthrust is smallest in that case, drag is then second number, and weight is the largest. So upthrust and drag combinedly, they will give you the weight of the object. Is this all clear? So when you are going to sink, or when you are going to move the object in denser fluid like oil, then for the same weight, terminal speed is achieved earlier for smaller height. That is why your density of the oil is greater than density of the air. So when you are going to drop an object, then it will gain terminal speed very quickly. So weight would be greater at that case, upthrust should be second greater, and drag would be uh, yani the smallest force. Yani drag and upthrust combinedly, they will be equal to what? Weight. So till this I have explained each and everything which will help you out to find out the questions of drag, pressure, and density behavior. And then in the next class, inshallah, I will talk about the tension, and then this chapter will be over.
Okay.
Is it all clear?
Yes.
So please, I'm just giving you some time for your self practice. That's why I did not finish this tension and drag together. So